Toppy time, the garden's mine. Dig it, drop it, water, pop it, sprout so fast you can't stop it. Little green buds doing the shimmy, turning the dirt into something pretty. Toppy, toppy, grow so snappy. Toppy, toppy, makes plums happy. Toppy time, the garden's mine. Let's grow and shine.
Hello, my friends! Today is a very, very special day, March 22nd, World Water Day.
But do we really know what water is? Let's find out!
Water is not just a combination of 2 hydrogen and 1 oxygen atoms, H2O. It is one of the most extraordinary touches of the universe.
All the magic of water comes from its geometry.
When the oxygen atom takes 2 hydrogen atoms by its side, they don't stand in a straight line. They form a V shape with an angle of about 104.5 degrees.
Oxygen pulls the electrons closer to itself. This causes one end of the molecule to be negatively charged and the other end to be positively charged.
Thus, water molecules act like tiny magnets. If it weren't for this, water would be a gas at room temperature instead of a liquid, and we wouldn't be having this conversation right now.
Water molecules are bound to each other with incredible loyalty. The positive end of one water molecule holds on to the negative end of another. We call this the hydrogen bond. These hydrogen bonds are weak. They constantly break and reform.
But there are so many of them that they give water high surface tension.
This molecular hand-holding is what allows insects to walk on water. Water also resists changes in temperature. It takes a lot of energy to heat up, and it releases a lot of energy as it cools down.
Thanks to this property, oceans act like giant energy reservoirs. They absorb heat during the day and release it at night.
If 70% of our bodies weren't made of water, our internal balance would break down instantly with even small temperature changes outside.
And why does ice float? Do we know that? Let's find out. Normally, substances shrink and become denser as they cool, meaning their solid form is heavier than their liquid form. But water does the exact opposite. After 4 degrees Celsius, it starts to expand as it gets colder. Usually, substances get heavier when they turn from liquid to solid. But our friend water doesn't really care about that rule. Ice is the solid state of water, and ice is lighter than water, so it floats. In other words, water just lifts the lighter ice right up.
Ice staying on top provides insulation for the water underneath, allowing life to continue, and, of course, letting us go ice skating.
In our How Old is the Soil episode, we talked about the Precambrian era of our world, which lasted about 4 billion years. Let's watch a short clip from that episode.
We are looking at what our Earth, which is approximately 4.54 billion years old, looked like during its first 4 billion years. This is the Precambrian period.
A long period of silence when even dinosaurs, birds, trees, and flowers didn't exist.
So, was there any life?
Yes, but only inside the sea.
While living in the ocean, the bacteria inside the sea slowly started giving the Earth the air, oxygen it needed to breathe.
And thanks to the big work of those tiny little creatures, the bacteria, which lasted for billions of years, the Earth slowly changed. And finally, the time came for the trees, the flowers, and most importantly, the soft soil that we know to be formed.
When life first moved from the sea to the land, it didn't actually leave the ocean behind. It carried the ocean within itself.
The fluid inside our cells, cytoplasm, and the liquid between them are surprisingly similar to the chemical composition, the salt and mineral levels of those ancient oceans.
So, in a way, we all carry our own private sea inside us.
Water is of course vital for plants too. Plants don't have bones. What keeps them standing tall is the internal pressure created by the water filling their cells. We call this turgor pressure. When a plant wilts, it's because this hydraulic pressure has dropped.
The magnetic quality of water, cohesion, allows it to be transported from the roots of giant sequoia trees to heights of 100 meters without a single pump.
Water molecules cling to each other, performing an impossible climb upward. We call this capillary action.
Water also plays the leading role in the story of human civilization.
We will dive into more detail about this in our next episode when we discuss irrigation techniques.
These miraculous physical properties of water have guided not just scientists, but also figures who have inspired the world with their wisdom. One of them is Bruce Lee. Bruce Lee describes the immense power of water, the way it fits into every mold but never gives up. Like this.
Empty your mind. Be formless, shapeless, like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash. Be water, my friend. Like that, you see?
As Bruce Lee said, water takes the shape of the container it is in, but it never loses its essence.
Water is what it is. It is flexible, powerful, and it is life itself. Just like water, human potential cannot be trapped in narrow molds, prejudices, or social limitations.
And that is precisely why the United Nations set this year's World Water Day theme by touching upon a very critical point: water and gender equality.
Because we know that when fair access to water is provided, not only thirst but also inequality ends. The abundance of water transforms into an equal future for every member of society.
Now, you too know the importance of water.
Remember, those who love the soil the most are the ones who know it best.
Join my adventures, learn, discover, and become a soil hero too!
Now, every weekend on Saturdays and Sundays, we will be together with our new adventures.
Don't miss out! Subscribe now and turn on notifications! It's time to explore!